welcome to Unit 10. All right, so this unit is all about quadratic graphs. So we're going to be talking about quadratic graphs in today's lesson. So an example of a quadratic equation is something like this right here. So y equals x squared plus 2x plus 3. So quadratic just means that there's always an x squared in there somewhere, and the 2 is the highest exponent. So this is the general form, the generic form for a quadratic equation. So we usually have something times x squared. So a lot of times a might be 1, so you might not see this a there. Plus something times x, and then plus some number. So when you graph a quadratic equation, the graph is always going to be a parabola. So a parabola just means that it's a U-shaped graph. So either like this, or upside down. So that's what a parabola is. So whenever we say parabola, we just mean U-shaped graph. So there is a line. There's always a line that goes right down the middle of a parabola. That is called the line of symmetry. So that's something we're going to have to find, but it's not too difficult. So the value of a in this equation, so a determines the direction the parabola opens. If a is positive, it opens up, so the graph will look like this. If a is negative, then the graph will open down. It'll be upside down U. So whenever we have a graph that is quadratic, or whenever we have a parabola, this point, so this is at the bottom of the graph, this is the very highest point of the graph. That point is called the vertex. So the vertex is going to be a very important thing that we're going to have to find in this whole unit. So if the parabola opens up like this one, the vertex is at a minimum point. The graph has a minimum. This vertex is at a maximum. This graph has a maximum, so it means it has a highest point. It's going up, 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 and then it stops going up and starts going down. This one's going down, 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 stops going down, starts going back up. So it goes up forever, but it does not go down forever because it has a minimum point. So another thing that we're going to talk about, something that you've heard about before, the domain is all of the x values in a graph, and then the range is all of the y values in a graph. So when I say all the x values, the domain just means what values of x does a graph touch. The range is what values of y does this graph touch. So if I go back up to this graph up here, this graph is going up forever and it's going left forever. So that's going to keep going on forever and ever and ever to the left. So it's going to keep touching all of these negative x values because it's going left forever. This side is going up forever and right forever. So it's going to keep going right forever. So it's going to keep touching every single x value as we move right and left. So that domain would be all real numbers. And in fact, in this class, the domain is almost always going to be all real numbers because the quadratic graphs always go left and right forever. However, the range tells me how far up and how far down the graph goes. So again, this graph is going up forever. So it's going to keep touching every single y value as it goes up forever, but it does not go down forever. So the lowest point it goes down to is where y equals 0 right here. So the domain, or excuse me, the range would be y is greater than 0 or equal to 0. Y is greater than or equal to 0. Because it touches 0, because this is where y equals 0, and then it goes up forever. And then, like I said, the domain is all real numbers. So this is one of those fancy R's. So it's just an R with 2 lines. That's one way to write all real numbers. You could just write out all real numbers if you want. But for me, this is quicker, so it saves me some time. All right, so moving on to example 1. So the first thing we're going to do before we graph this is we're going to fill in our table. So y equals x squared is our equation. So if x is negative 2 squared is 4, because negative 2 times negative 2 is a positive 4. Negative 1 squared would be 1. 0 squared, 0 times 0 is 0. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. So I got 5 points for this graph. Let's use a different color. So we got a point at the origin, -2, 4. So that means I got left 2, up 4. -1, 1. So left 1, up 1. 1, 1, right 1, up 1. And then 2, 4, right 2, up 4. So I could put more points on there if I wanted, but I can already see the U shape that it's forming, or the parabola shape. So our graph will look something like that. So we need to find the vertex, the line of symmetry, whether it has a minimum or a maximum, the domain, and then the range. So the vertex, again, is whichever point is either lowest or highest on the parabola. So this one has a lowest point because it's going down, 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 and then starts going back up. It goes up forever, but it does not go down forever. So this point would be the vertex. So the vertex is at the origin actually in this one, so it's 0, 0. The line of symmetry, so which line, or where could I draw a line that goes directly down the middle? So that would be right through there. It's always going to go through the vertex. And it's always going to be a vertical line because parabolas are always vertically symmetrical. So whatever the x value equals in the vertex, that's going to tell you what the line of symmetry equation is. So x equals 0, because the equation for a vertical line is x equals some number. Since the vertex has the x value 0, then x equals 0. This graph does have a minimum because this is the lowest point. It does not have a maximum because it goes up forever. The domain, so this side is going left forever. This side's going right forever. So again, domain is asking how far left, how far right, or what x values does it touch. So it's going left forever, right forever. So it's going to eventually hit every single number. So I'm going to call that all real numbers. The range is asking how far up and how far down the graph goes. So it goes up forever, but it stops going down right here where y equals 0. So that means y is either greater than or it's equal to 0. So that's example 1. So example 2 is pretty similar, just a different equation. So this time we're going to graph y equals -2x squared. So again, we're going to use this table. So -2. Oops. Erase that. So we got a -2, and then I am substituting -2 in for x squared. So exponents come first. So -2 times -2 is +4. And then -2 times 4 is -8. So -1 squared is +1 times -2 is -2. And then if x is 0, 0 squared is 0, -2 times 0 is 0. If x is 1, 1 squared is 1, 1 times -2 is -2. If x is 2, 2 squared is 4, -2 times 4 is -8. So now I'm going to graph these 5 points. So -2, -8. I got left 2, down 8. 1, 2, 3, 4, 5, 6. Oops, I did not go far enough. 1, 2, 3, 4, 5, 6, 7, 8. Then -1, -2, left 1, down 2, 0, 0. Right 1, down 2, and then right 2, down 8. So we got our little U shape. So again, parabolas always go on forever in one direction, either up or down. So always put your arrows at the end of these. So the vertex is the point where the graph changes directions. So the vertex again is at the origin, so 0, 0. The line of symmetry goes right through the vertex in a vertical line. So if x is 0 on the vertex, then x equals 0 will be the line of symmetry equation. This graph has a maximum because it has a highest point, so it's like a mountain. You can climb up all the way to the top, has a maximum point. And then the domain, so how far left and how far right, it's going right, or excuse me, it's going left forever, and it goes right forever. So the domain will be all real numbers, because eventually it's going to go all the way left and to infinity. It's going to go all the way right to infinity. And then the range, so its highest point is 0. So it goes up to 0 and then it goes down forever, down forever. So all the y values are either equal to 0 or they have to be less than 0, because these are all below 0. All these points on this parabola are either less than 0 or there's one on 0. So y could either be less than 0 or equal to 0. So moving on to the next page, another thing that we're going to have to find, and a lot of people have trouble with this, even though it's not super difficult, but the average rate of change. So if you practice this enough, it won't be too hard. It might be hard at first, but the average rate of change is basically like finding a slope. So if you remember in Math 1 or Math 8 or any previous math class how to find the slope, oops, it's not y though, m equals y2 minus y1 divided by x2 minus x1. When we're finding the average rate of change, so we're going to get to this example eventually, but this says find the average rate of change from x equals 0 to x equals 1. So x equals 0 is right here, and then x equals 1 is that point on the graph. So basically, I'm trying to find like the average slope between these 2 points on the graph. Normally, when you find slope, you're finding the slope of a line, but obviously this is a parabola, so it's curved, so it's not a line, so we can't just find the slope. So we're finding like the average slope between those 2 points. So that's what it's saying when you're finding the average rate of change. So that's kind of what this explains up here. I'm going to skip down to example 3 right here. So if I wanted to find the average rate of change of f of x equals x squared from x equals 4 to x equals 8. So I'm just going to say that A rock, the average rate of change, is equal to y2 minus y1 divided by x2 minus x1. So whenever we're finding the average rate of change, they always give us the two x values. So on x goes on the bottom, so I like to put the highest one first. So 8 minus 4 will be on the bottom. To find the y values, or the f of x values, I got to plug in the two x values. So if I plug in 4 to x, f of 4 equals 4 squared, so that's 16. If I plug in 8 into x, I get 8 squared, which is 64. So when I plugged in 8, the y value was 64. When I plugged in 4, the y value was 16. So that's how I get the two y values. So 64 minus 16 is 48. 8 minus 4 is 4. And then 48 divided by 4 is 12. So the average rate of change between where x equals 4 and x equals 8 is 12. So basically, you're just finding the slope. So example 4, we got to find the average rate of change between these two, and then these two. So the equation is y equals x squared. So the average rate of change is equal, or the AROC, is equal to y2 minus y1 divided by x2 minus x1. So this is something that's going to be on the test for sure. So make sure you know how to do this. So the two x values are always given. So we're going to start with 0 to 1. So that means 1 minus 0 will go on the bottom. If I plug in 1 into x squared, I get 1 squared, which is 1. If I plug in 0 into x squared, I get 0. So 1 minus 1, or excuse me, 1 minus 0 divided by 1 minus 0 is 1 divided by 1, which is 1. So the average rate of change between where x equals 1 and x equals 0 is 1. So then I'm going to find the next one. between 1 and 2. So 2 minus 1 will go on the bottom. And I plug these two numbers into the equation to get my two y values. So 2 squared is 4. 1 squared is 1. So 4 minus 1 is 3. 2 minus 1 is 1. So the average rate of change is 3. So the average rate of change between where x equals 1 and x equals 2 is 3. And then finally, the average rate of change between where x is 2 and x is 3. So on the bottom, I'm going to have 3 minus 2, and then I plug these two into the equation. So 3 squared is 9 minus 2 squared, which is 4. So 5 divided by 1, which is 5. So the average rate of change between where x is 2 and x is 3 is 5. So again, to get the bottom numbers, you just use whatever they give you. To get the top numbers, you use those two numbers they gave you and put them into the equation, whatever the equation is. In this case, it was y equals x squared. All right, so maybe you see a pattern developing here. The average rate of change went up 2, and then the average rate of change went up 2. If we found the average rate of change between 3 and 4, you could probably guess it would be 7. So it just keeps going up by 2. So we're going to use this pattern throughout this unit to make graphing easier. So as x increases by 1, y increases by 2. So there's a little pattern formed for the average rate of change. So I'll talk more about this in the future. But I know the notes are really long, so I'm going to try to move on. All right, so let's finish these things on example 4. So using the average rate of change, so we got one more page. So these equations are already in vertex form for us. So if it's in vertex form, you'll have parentheses and squared and then plus or minus some number out here. So to get the vertex, when it's in vertex form like this, you take this number, change its sign, and that's your x value. So -2, and then this number with the same sign will be your y value. So the vertex is -2, -3. And now I'm going to use that pattern that we just talked about up here. So 1, 3, 5, 7. So 1, 3, 5, 7. This will save me time graphing. Instead of making a table like we were doing before, I can just use these rates of change, average rates of change. So if this is the vertex, and keep in mind there's no a value over here. So the a is just 1. So the first average rate of change I'm going to have is 1. So that means I go up 1, right 1. I do the same thing to the left because these are symmetrical graphs. Then from this point, the next rate of change I'm going to have is 3. So that means I go up 3, right 1. Do the same thing on the left, but I move to the left. So up 3, left 1. Then I do 5. So up 5, right 1. Same thing on the left. And I don't have room to go up 7, so I'm just going to stop right there and make my little U shape. So again, this, if you can figure out how to do this, it's not that hard once you practice a little bit. It'll save you a lot of time graphing these things. So that's it. That's all we had to do for that one. So the next one, the vertex, this number with the opposite sign. So +1 is your x value, and this number is y, so +2. So vertex is at 1, 2, 1, 2. This time we have an a value. So whenever we use the pattern, we have to multiply the pattern by whatever a is. So instead of 1, 3, 5, 7, blah, 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 we're going to have -2 times 1. So -2, -2 times 3 is -6, -10, and so on. So these are going to be our average rates of change now. So instead of going up 1, right 1, I'm going to go down 2, right 1. So down 2, right 1. I do the same thing to the left, down 2, left 2, or down 2, left 1, excuse me. Next, is -6. So I go down 6, 1, 2, 3, 4, 5, 6, right 1, down 6, left 1. I don't have room to go 10, so that'll be it. And my graph is done. So this is kind of explaining vertex form here. So there's a couple more examples. You guys can do these on your own, but these notes have taken forever, so I'm going to end it right there.